My name is Edson Chikati. I am a PhD student at California International University. I'm going to make a presentation on hypothesis testing. The layout of my presentation is as follows. 1. I'm going to introduce the concept of hypothesis. 2. I'm going to present on hypothesis testing, covering the following areas: test for a mean, comparing two groups, efficiency comparison, and correlational test. 3. I'm going to give important takeaways, and on the last slide, I'm going to invite comments and questions. Introducing hypothesis testing. The definition of hypothesis testing is as follows. It is an educated prediction which is specific, researchable, and testable. A hypothesis is a working statement which is a default position accepted on the assumption that it is true, or a proposition which can either be supported or refuted by empirical evidence from the research data. It is likened to what in law is termed "you are innocent until proven guilty." There are two important concepts attached to hypothesis. The first one is the null hypothesis, denoted by HO. It is the proposition that implies no effect or no relationship between phenomena or studied populations. There's also an alternative hypothesis, denoted by HA. It is the opposite of the null hypothesis, which states that there is a difference. This difference is called statistical significance, or an effect between two or more variables being studied. These two concepts, they co-vary. I move on to another concept called hypothesis testing. It is a process of gathering empirical evidence to substantiate or reject the working statement. This empirical evidence is important. That's where the scientific approach comes into play. Another concept is the region of acceptance. This is a determined region by the researcher, depicted by the significance level, which is arbitrarily chosen prior to conducting the research, and is measured by the p-values. There are also two important concepts, namely confidence level and significance level. The researcher determines the confidence level upon which he will accept or reject the level of evidence that is gonna get from the research results. For instance, if the researcher chooses a 95% level of confidence, it therefore means the significance level is 5%. When you add the two together, significance level and confidence level, you must get 100% or a 1. The p-value is a measure of the strength of empirical evidence against the null hypothesis. The strength determines whether to reject or fail to reject the null hypothesis. If, for example, the p-value is less than the alpha, this demonstrates a very strong empirical evidence against the null hypothesis. The decision, therefore, is reject the null hypothesis in favor of the alternative hypothesis. If, however, the p-value is greater than alpha, this demonstrates weak empirical evidence against the null hypothesis. The decision, therefore, will fail to reject the null hypothesis, which means we accept the null hypothesis and reject the alternative hypothesis. Hypothesis test for a mean. The question here is, on average, are the widgets from Acme Widget Company defect-free? My null hypothesis derived from this research question is, there are no defects on widgets from Acme Widget Company. Conversely, the alternative hypothesis reads, widgets from Acme Widget Company have defects. Moving on to the test comparing two groups. The research question reads, does the average major league team have more home run hitters than its corresponding minor league team? My null hypothesis reads, there is no difference between the average major league home run hitters and the minor league team. The alternative hypothesis is, there is a difference between the average major league home run hitters and minor league team. Moving on to hypothesis test on efficiency comparison. We have here the blue color, which depicts a single queue with a single servers in sequence, and the red color depicting a single queue with multi-servers in sequence. The research question is, the efficiency curves of the red and blue teams were recorded. Do the teams have equal mean efficiencies? The hypothesis I derive from this research question reads as follows. The mean efficiency of the red and the blue teams are equal. Alternative hypothesis is, the mean efficiencies of the red and the blue teams are not equal. Hypothesis test on correlational. This scenario, which is a German study which tested how larger industrial use vans utilized gasoline. One of their analyses plotted the mile per gallon versus the weight of various vans in the study. After plotting the data on a scatter plot, the researchers performed a correlational test and found a significant correlation. However, they forgot to state their hypothesis test in their published paper. The important question now is, what were the study's null and alternative hypotheses? From this scenario, my null hypothesis reads, there is no relationship between miles per gallon and the weight of industrial use vans. Conversely, the alternative hypothesis reads as follows. There is a relationship between miles per gallon and the weight of the industrial use vans. From the test results, there is empirical evidence against the null hypothesis. This is also demonstrated by the line of best fit, which shows significant correlation. The decision, therefore, is that we reject the null hypothesis in favor of the alternative hypothesis. Important takeaways on creating hypothesis test. The null hypothesis works on an assumption of a working statement which is acceptable until proven otherwise. Empirical evidence from the data facilitates a decision to either reject the null hypothesis. To reject the null hypothesis, there should be strong empirical evidence against the null hypothesis in favor of the alternative hypothesis, or there will be weak empirical evidence against the null hypothesis. The decision, therefore, is we will fail to reject the null hypothesis, which means, in other words, we accept the null hypothesis and reject the alternative hypothesis. Important takeaways on using visualizations. Visualizations capture attention, aid sense-making and understanding to both the researcher and the audience. Visualizations give a snapshot of the story that the researcher is discussing, or of the story that the reader is reading. 2, we have one-tailed or two-tailed tests. When an alternative hypothesis has a less than sign, the shaded area is on the left. Conversely, when an alternative hypothesis has a more than sign, the shaded area is on the right tail. We also have a situation where we have a two-tailed test. This arises when we have a non-directional theoretical reason. We find ourselves having two tails on either side. The shaded areas will be under the curve. I want to thank you for watching this video. Now it's time for comments and questions. I thank you.